So as I said, we started the company in 2008. The first 2 years, I have an amazing CTO who convinced me that we had to go and build our own database on top of everything else. So in 2010, we released our product, and the first product we released is basically website monitoring and one synthetic node in Las Vegas out of all places, because if you have bad performance, what happens in Vegas stays in Vegas, right? So that was the whole notion. The product was launched on April 1st, 2010, no joke, but it was the synthetic monitoring. So that's what we did. Over the years, we basically took that product and made it better, stronger, with more vantage points where we measure from. So think about us like the synthetic monitoring capability is we are the earthquake detection system of the planet. So we have 2,700 sensors around the world, because you don't want to detect an earthquake in California from Tibet. That doesn't make sense, right? So we have sensors everywhere, 2,700, and that's growing. And those are running in cloud, those are running in our own data centers, these are running in little devices that we pay people to host at their house, because we want that last mile visibility. It's running on wireless, and more to come soon. So the synthetic monitoring is this ability to pretend to be a user and to be able to do various tests of DNS, of web, of APIs, of whatever you want, actually. So it's literally the sky's the limit. It's like mystery shoppers, right? Mystery shopping was invented in the 1800s. It is the ability to send someone to a coffee store or to a hotel and say, hey, is the rooms clean? They would have failed at this hotel, by the way, but that's a different story. So synthetic monitoring is that. Real user monitoring is the ability to passively suck all the data that every user has with your website or your web application. So it's like, instead of a network sniffer, it's a JavaScript sniffer. So think about it like Google Analytics, but for IT guys, right? Or IT gals, I should say. Endpoint monitoring is something that came out during COVID. So the synthetic monitors that we have, customers started deploying them in call centers, inside the firewall, to basically do what is called either first mile testing, or just like, hey, we have a call center in the Philippines, we're trying to understand why there are issues. But then when COVID hit, I got a CIO call me one day and said, okay, Mehdi, we used to have your nodes, your synthetic nodes in 3 of our offices. I have 3,100 office now. What are we going to do about that? It's like, well, you're going to buy 3,100? Like, no. So, because we can't ship 3,000 servers to 3,100 employees, it doesn't make any sense. So we got to work. We took our best capabilities, our best engineer, and we basically took our product, shrank it, and put it on the end user. So on your laptop, on your desktops, and now we can basically capture performance and telemetry, Wi-Fi telemetry, network telemetry from the actual end users, but in a synthetic way as well, which is really powerful. So that was endpoint monitoring. Sometimes crises push you to co-innovate with customers, which is great. BGP monitoring was launched in 2019, and I told you we have an office in Italy. We basically needed to shore our capabilities with real BGP monitoring, and we were a little bit lacking there. Actually, we were terrible, I should say, even, and we needed to get better very quickly. So we found these 2 guys. We fell in love with them. They're in Pisa, and we basically built a BGP capability around these 2 guys. They used to work for the Italian government, or the Italian university, sorry. And we brought them at Catchpoint, and we have now a team of 10 people in Italy, amazing. And then I get to eat pasta, real pasta, once a year when I go and see them. But the BGP team did an awesome job. Web Page Test was an acquisition. And then the other acquisition we just did last year in Turkey is a company called Tundra. And Tundra is in the open telemetry and the tracing business. And the reason we went there is because customers kept talking to us about, well, that's great, you detect a problem on the left side, but then if I want to go and see what's going on inside, I have to go and look at another tool. I have to use another tool. Is there a way to combine? And there are some amazing capabilities, some amazing tools out there in the observability space, Datadog, Dynatrace, etc. But some customers don't want that big heavy lift. They just want, hey, can I just be able to do a trace, simple, cheap way? So when the Tundra acquisition presented itself, we jumped all over it, especially with OpenTelemetry. So OpenTelemetry, as you probably know, there is a movement that started about a few years ago that was just like, okay, we don't want to be tied to specific vendors. We don't want to be locked into an agent on a box, something like that. And we also want to enable our developers to just instrument the applications the way they should be instrumented. So OpenTelemetry is a great movement, big supporter of that, and that's taking off. The latest innovation that I will show you today is Internet Sonar and StackMap. Internet Sonar came from the conversations we've had with customers over the years, which is like, hey, Catchpoint, you detect a problem, but I need to know if it's the network, if it's the internet, if it's somebody else. Because we never like to admit that it's us, right? So we're going to blame everybody else first, or the meantime to innocence, as we call it. So Sonar basically looks at the 50 billion events we capture every day to basically paint a picture of like, hey, what's going on the internet? So think about it like a weather map. It's like, hey, there is a cyclone in Atlanta right now, or some major thing that can basically help you understand, is there something that is going to impact my user experience somewhere? So Sonar is a new addition to Catchpoint.
So with Sonar, just a thought, right? So we now have large global events
Yes.
that happen.
Yes.
Some negative, some positive. Positive one coming up in Paris. We're going to have the Olympics.
Yes.
I mean, I'm assuming that these products, I mean, you heat map that you can see the global impact on traffic when you have all these users and this activity happening during a period of time.
Correct.
That's awesome.
Like, how do you use that data? How do you use that data to inform customers, advise them, and because we know it happens.
Sure.
Right.
So our customers have access to this. I have a philosophy, maybe right or wrong, time will tell. I've never been a huge fan of taking a megaphone and screaming, oh, somebody is down or somebody is having a problem, or shaming. I'm not a public shamer kind of guy. I'm not, I don't buy into that. Because by the way, sorry, I lied. I did it once and I lost that customer, and I promised I'll never do it again. So a prospect, I should say. And so we're not into the public shaming business, but our customers have access to that data. It's available to them. We are coming up with the quote unquote free version of Sonar, where on our website you'll be able to see all the internet outages and all the internet big events that we see. So whatever we see, you'll have a view, but then only our customers will be able to dive in. But it's good enough to say, hey, is it sunny in Paris right now?
Yeah, well,
or do you need to take an umbrella?
But more to my point, right? Like when these activities happen, whether it's the Super Bowl, whether it's sometimes a natural disaster, sometimes it's a great event like the Olympics, it puts new tax on the cellular network, puts new tax on, undersea cable networks, phone networks.
Absolutely.
Right? Like it, and
we just saw that in Africa when there was the subsea cable.
Yeah.
A lot of our customers that were impacted, big social media companies and whatnot, their performance went from like 30, 40 milliseconds to 5,000 milliseconds.
Yeah.
I mean, insane impact. So absolutely.
So, but with that, I guess my thought process is, companies either need to make decisions to ensure that they're going to expect higher latency, and how do they respond to it? What can they do to ensure that, when there's these high traffic, not necessarily outages, but like you're going to get higher latency, you're going to have lower response times because there's so much congestion. I mean, now it informs like when you create your application, you create your website, maybe you need to turn these things off during these periods of time. But being able to inform them to do that, I think is really powerful.
So once you know, then you can the first thing to do is like, maybe there is nothing I can do about it.
But sometimes, absolutely.
And that's amazing, because what you don't want is a crisis and a fire and everybody screaming and jumping.
Yeah, it's like, why is latency so bad? Why
there's nothing you can do about it, right?
Like, so
unless you can go and run a cable yourself undersea, there is not much you can do. Thank God Google was there and helped everybody else that day. But besides that, there is not that much you can do. But you're absolutely right. There is optimization techniques, like maybe, hey, can you spin off another instance of something on a different cloud vendor that has maybe a different path to those users, maybe something more regional. But that's exactly it. Data, what gets measured gets improved, right? It goes back to this thing.
100%.
The more information you have about your body, your ecosystem, you can impact it. But that's exactly the use case. So again, we talked a little bit about the world's largest network. So speaking of Paris, I think we have like 40 locations in Paris, and we've been bumping those up because a lot of customers are worried about what's going to happen to their stuff from France during the Olympics in a few weeks. But this is literally one of our key thing, is like our vantage point and where we measure from. So again, these mystery shoppers. Imagine if you were running a hotel company and you contracted with a mystery shopping company and says, sorry, I only have one mystery shopper and he's busy. Now we have 2,700 of them. We're in 297 cities, 94 countries, Africa, Latin America, China, which is one of our biggest use cases, actually China monitoring, right? If you have an e-commerce or anything and you care about the Chinese performance and the impact of the Chinese firewall, the great firewall on your users and your applications, we are the perfect solution for you. All right. So Internet Stack Map is something that we just released. This is, to be honest, one of my proudest moments in the last 15 years. Because finally, technology is allowing us to basically create a visualization of your internet stack, of like what I've been telling you about. We're now able to visualize it and show you which DNS provider is having a problem and impact on your user experiences. And being able to allow, and Brandon is going to give you a live demo of it, which will do more justice to a PowerPoint slide. But Internet Stack Map is we're allowing our customers for the first time to see that dependency, those dependencies, and the impact of those dependencies. And again, technology didn't exist 10 years ago to do this. So, and it's fueled by Sonar, which is a lot driven by some of our AI capabilities as well. So, yeah.
Sorry, on that last one.
Yes, sir.
Not to get too tactical, but the underlying technology, do you allow to connect into like Prometheus and GraphQL?
No, this is all of our Catchpoint data. So there is a discovery. We discover things. There is and Brandon will show you that there is an auto discovery capability. There is also the ability for you to manually add stuff, and then we're going to keep adding more. There is an integration that is coming with our APM, our observability acquisition Tundra, right? So you'll be able to go from here all the way to the trace. And then in the future, yes, we will plan to do integrations.
Okay, so if somebody's using those other platforms, they still have to use your view. Okay,
correct. So going back to Sonar, right? So global outage detection of services and also network issues. So being able to also understand, hey, there is a problem in Beijing or on Cogent or NTT, and there is basically a subsea cable issue, being able to detect that. So this is actually a new thing that we just released a few months ago. And Sonar, the first one was like allowing people to see outages. So we had our aha moment with this when there was an Adobe outage a few months ago. The Adobe Tag Manager had a little glitch, and a lot of websites went completely kaput. It reminded me of my stupid mistake at DoubleClick, where I literally took down websites. So the same thing. And this is where customers were able to see within seconds, not hours, not by scrapping some status page, but literally because of our data that we collect, that, hey, there is an Adobe outage. Yeah. There is nothing you can do about it.
You don't have to wait for the Associated Press to announce it.
You already know what's going on. And the action is just remove the Adobe tag from your web pages and problem gone. And the ones that did not were scrambling on crisis calls, hundreds of people on a call trying to figure out what's going on. So again, it answers that question, is it me or someone else, right? That's literally the old history is like, is it me or us? Anyway, so again, we talked a lot about user experience. We talked a little bit about Internet Stack. Now there is application. And application, again, and you guys are all more familiar with this, we don't want to go full application monitoring. I think there are some great companies that do an awesome job, and there is nothing I don't think we have the firepower to displace those guys. However, I think there is a play for Catchpoint where we can answer those questions faster. Again, my mission, and the mission of Catchpoint at the end of the day is to reduce mean time to repair. That's the only thing I live for, is how can I reduce that mean time to repair? And mean time to repair is an equation. It starts with, are we having a problem? Detect, identify, escalate, fix. Hopefully AI will fix automatically. But then you have to validate that, is the problem gone? Right? I still go every 6 months to get my logs checked because somebody has to verify that I don't have bad habits again, right? So
I'm sorry, you're saying mean time to repair?
yes. Every CIO.
There's mean time to repair, love that.
Yes.
But the first stage to me was mean time
Detection.
back to user,
Yeah. Oh, interesting.
right?
Yes.
I mean, in the enterprise app world, you talk about the response time to port,
Yes.
availability and response
Yeah.
time to the port, right? Here we're thankfully taking it back to the user all the way back to the user
Correct.
experience. So in this perfect AI enabled world that Alan is driving us towards, there will be nothing to repair anymore, but there still will be all kinds of messiness between the functionality and the user.
Correct.
And it seems also that that's not necessarily something to repair so much as to work out, train, improve, strengthen. Yeah.
Yeah.
Okay.
That's exactly it. And it's not only the users, because one thing we're noticing, I mean, one of our fastest growing segment of utilization of our system is APIs. And what we're seeing is that, yes, the user experience is important, but machine to machine, one of our biggest customer is this car manufacturer that literally we monitor the robots that are making the cars. Because there is a user experience, except that it's not Jane and Joe, right? It's machine 101 that is actually putting things together. And that has a user expectation, a user latency expectation that is critical. But going back here, we want to help, again, reduce this mean time to repair. And I think tracing is going to allow us to do that. And so being able to understand all the way from the end user to the applications. But we are paranoid about the end user. Like, all I care about is the end user. Everything we do on a day, when we wake up and build features, it's end user centric mindset.
Yeah, so you're not going to be providing or worried about tracing between, let's say I have an application where, data gravity dictates I'm going to be on US East with Amazon, or, I'm going to be in the Pacific Northwest with Azure or whatever. But like, I've got data gravity here, my applications, and know I'm going to have latency between the East Coast and West.
Correct.
You're going to be looking at the network, not the provider themselves.
But even the provider, because we're coming again from the end user, so I'm going to do two things. There is the actual real human being that is transacting with your app. I'm collecting that data with real user monitoring, and we're tying that to OpenTelemetry as well. So that's one path, that's one data source. The other data source is I have these robots that are constantly probing a checkout, a banking, ordering a book, whatever it might be, ordering a car. And so we, Catchpoint, is probing. And so the synthetic agents are doing those tests every minute, every second in some cases. And then we're capturing all the way now through the code because of OpenTelemetry. And I can tell you, hey, there was a probe issue from Paris at 2 o'clock in the afternoon. It was a network issue. Go and deal with that. Or it was an app issue, and here is where it was. And yes, there might be a connectivity between the application, the database, or something else. Mm-hmm. Because OpenTelemetry is giving us all that data. But we're blurring a little bit the lines, but it's really about answering the question. Yeah, sorry.
So we're talking about kind of the user perspective, the outside-in perspective quite a bit.
Yes.
The thing that I wonder, and I did a lot of work with, when I worked for an e-commerce platform a couple of years ago, where instead of looking at the actual current performance and any problems, I didn't necessarily want to know where those current problems were. I wanted to know where my future bottlenecks were. So I did a lot of load testing in conjunction with real user monitoring, for instance. So my question is, how does load testing fit into what Catchpoint does?
Good question. Thank you for that. So we don't play in the load testing business. We partner with a lot of our companies and that do that. There are some really good solutions that do load testing. Believe it or not, we have a lot of customers. I mean, probably have 100 customers in e-commerce. Some of the largest e-commerce actually the largest e-commerce companies use Catchpoint, and we play a critical role in the Black Fridays and the Cyber Mondays of the world. And what we realize is, yes, your load testing is good at being able to figure out the high-level bottlenecks, right? But there is one thing that they cannot do is understand how a Black Friday, the same way you asked the question about Paris, how is the overall network connectivity or the overall user behaviors happening in Minnesota, for example, are going to impact Best Buy because your load testing happened at a particular given time. Now, you can wait for the real user data to tell you, hey, oh man, you have a problem. All your users are having an issue in Minnesota. But why not be more proactive? Why cannot you do that testing more proactively, continuously, 24/7? At 7 a.m., why not fix the problem at 7 a.m. when that monster, that performance monster starts showing its ugly face? Why wait until 7:10 when it's hard down? So load testing is imperative, right? That's why you go and you do your cardio fitness test once a year. You have to go and do your stress test. That's very important. But throughout the year, throughout your day, you need to do continuous performance testing and monitoring. So testing and monitoring are two separate things, right? And so I just look at that as separate. Now, tactically, another thing that we did is web page test. So web page test is this great solution that was developed by Patrick at AOL, then sold it to us. But one of the things that we are heading with web page test, because it's such a great tool at detecting potential performance problems, and we use AI, although it wasn't called AI a year ago, but is the ability to do what we call experiments. So imagine if you have a developer that literally runs a web page test on your web application, again, e-commerce, banking, whatever, and the system tells that person, hey, we've detected these 15 performance issues, but I have to go and talk to the engineers, go to Scrum or Agile and say, hey, can you go and put these 15 fixes together? But you're not sure if you're going to have a performance benefit or not. So with web page test experiments, what you're able to do is pick and cherry, add them to your basket and say, hey, can you run this experiment for me and see if there is going to be a performance improvement for the end users down the line? And so we basically do simulation and say, hey, you know what? Out of those 15 experiments, only 2 have a performance improvement. The rest, garbage, don't do them. They're going to hit you. Because everybody has like, oh, let's do these 15 things or 5 performance improvements. But every page is constructed so differently that the impact is different. So that's web page test, and of course, RUM. On the network side, there is one area that we're seeing a tremendous ability for Catchpoint to help people bring a flashlight to the war room is the network, because this is one thing that is still very, very complex. Not everybody has an advanced degree in network or network troubleshooting. But this is super important. The fact that people are using quick protocol, which is a UDP-based kind of thing, to deliver better performance in the application is very obscure. We worked with a great company to improve ECN, which is this protocol that was built in the 70s that suddenly has become so much more popular across some ISPs to detect and route packets more efficiently. Anyway, so the network stuff is becoming really, really interesting for us, both from a product perspective, but also some of the problems we're solving for our customers.